I'd like to talk about the theorems that you will use in your 7.1 and 7.2 homework. They are listed here. They should already be copied on your theorem sheet. If they're not, please pause the video and copy them now. When you're ready to go on, press play again. Theorem 50 says the sum of the measures of 3 of the angles of a triangle is 180. I'm sure that you already knew that, but I want to show you visual proof that will allow you to conclude that measure of angle 1 plus measure of angle 2 and measure of angle 3 sum together to be 180. In order to do that, I draw a line parallel to one side of my triangle, and then I extend these segments over here. So that line extends that way, this line extends this way, and they're straight. Okay. Now, I know that these two angles are congruent because they're vertical angles. In addition, I know angle 3 is congruent to this angle because those are corresponding angles and lines are parallel. And I know angle 1 is congruent to this angle up here because those are corresponding angles as well. So you can see that all 3 of these angles lie on a line and they sum to 180, and so do the angles inside a triangle. The next theorem is Theorem 51. We've talked about this before. The sum of the remote exterior angle right here. The exterior angle of a triangle. We create an exterior angle of a triangle by extending one of the sides of the triangle. So angle 1 is an exterior angle. The measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. And this really comes from the triangle sum theorem. I can see that measure of angle 2 and measure of angle 3 added together with the measure of angle 4 have to be equal to 180. Because they're inside a triangle. Now, I also know that the measure of angle 1 plus the measure of angle 4 is 180, and that's because they form a linear pair. They both lie on a line. So you can see that the measure of angle 1, oh, don't like that. Hold on. I was trying to use a highlighter. Let's try it one more time. The measure of angle 1 has to be the same as the measure of angle 2 and the measure of angle 3 added together. So again, the exterior angle of a triangle is equal to the sum of the remote interior angles. Remote meaning the angle that's not right next to angle 1. Theorem 52 says a segment joining the midpoints of 2 sides of a triangle is parallel to the third side, and its length is 1/2 the length of the third side. They call this the midline formula. Sometimes we call this the mid-segment. Depends on the book. The midline or mid-segment is the segment that joins the midpoints of 2 sides of a triangle. So what I have drawn up here, on here, is the mid-segment. From here to there. That is the mid-segment. It joins the midpoint of 2 sides. Now, according to this theorem, this segment has to be parallel to the opposite side. And that will allow me to conclude various things about the angles. For example, this angle is congruent to that angle because they're corresponding angles, and so on. Now, if this is the length of the midsegment, if the length of the midsegment is A and the length of the opposite side is B, I know that A has to be 1/2 the length of the opposite side. Theorem 53 says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. They call it the no-choice theorem. So if I have two angles congruent to two other angles in another triangle, of course these angles have to be congruent because the interior angles of a triangle add to 180. And finally, the last theorem that you will use in your homework is this one. If there exists a correspondence between the vertices of two triangles such that two angles of a non-included side of one of the congruent, let's start over. If there exists a correspondence between the vertices of two triangles such that two angles and a non-included side of one are congruent to the corresponding parts of the other, then the triangles are congruent. So let me draw you a picture. I'm going to label my vertices. And what this says is if I have a set of angles in the non-included side, meaning the side not between angle A and angle B, but outside. It could have been CB and it also could have been CA. And in another triangle, I have two angles that are congruent to the first triangle. And again, I have another side outside of those two angles. Then these triangles, and I'm going to name them, are congruent. And notice how I name them. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. And again, I'm pretty sure that you saw this theorem last year. Angle, angle, side. Meaning I have two sets of angles. 1, 2. And I have a set of sides congruent. And you'll notice the S is not between the A's. In other words, it is the side outside of the angles. So those are the theorems that will be used in 7.1 and 7.2 homework. I will talk to you more about it in class.